Okay, we're live, and welcome to the somethingth number virtual jug session, something like 80th or something around that number. And today we've got an interesting topic actually on testing, and it's interesting not just because of the topic, but because of the number of people that we've had RSVP to this meetup. Last I checked, actually, Oleg, could you just quickly check for me how many there are exactly? Last I checked, there were around 770, which is important because our
773. It's a drum
oh,
roll.
so close. So 776 was our previous highest RSVP. So Nicolai, sorry, you're gonna have to suffer second place behind Venkat, although Venkat's a very good person to be second to. So let me introduce you rather than just talk about you, Nicolai. Nicolai, welcome to the Virtual Jug. We're very pleased to have you. And this is your first session on the Virtual Jug, right?
Yes, exactly.
Excellent. Well, the very best wishes on the Virtual Jug. And joining us as well, Oleg. How are you doing?
I'm doing pretty well. Just trying to figure out the RC situation on the Virtual Jug channel on the RC.
Perfect. So everyone should hopefully be joining now. And while everyone's joining, I'm going to quickly share my screen. Let me quickly do that here. Entire screen share. Click on that. Click hide and jump to
Keynote. That's beautiful.
How's that? It is nice, isn't it? Nice bit of recursion there. Everyone can see that, hopefully, right? My screen? You can see my screen?
Yep.
Excellent. So this is JUnit 5, next generation testing on the JVM, and for those of you who don't know, JUnit 5 is well, I'm sure Nicolai will be telling you this, but JUnit 5 is one of the latest version of JUnit, and there was a lot of interesting information, a lot of interesting updates into this, which Nicolai is going to be talking about. If you wanted to follow Nicolai Parlog on Twitter at NIPAFX, NIPAFX, and do follow Nicolai. The Virtual Jug is sponsored by Zero Turnaround, and media partner is Rebel Labs. Zero Turnaround are a producer of revolutionary developer tools, and creators of two tools which I'm sure you're no doubt aware of. JRebel, the tool that allows you to reload code changes instantly. So write your code in an IDE and see them instantly in a browser, without needing to do your build, redeploys, and all those kinds of horrible things which we hate waiting for. Also, XRebel is a lightweight Java profiler that allows us to profile or get performance data on our Java web apps while we're writing the code, so no need to wait till the more expensive testing environments or even production. A couple of other things I wanted to mention before we get started. If you want to engage with everyone on the Virtual Jug on this live session, you're welcome to. We're on Freenode, pound or hash. Virtual Jug is our channel, so do go there for any questions, and we'll relay them to Nicolai, or if just for discussion. Also, please do share the group and this session on Twitter. So if you've got a Twitter account, do tweet about it right now. Send the link out and tell people what you're looking at, because it's very important we grow as a community. And as ever, feedback can go to @VirtualJug or @SJMeeple about this session or about the VJug in general. The VJug 24 is a 24-hour conference which will be running the week after Java 1, which is the 27th, I believe, of September. And me and Oleg are currently going through all our CFP sessions, and we're going to create a schedule for you hopefully next week. So do look out for that. And this is 24 24 contiguous sessions. That would be a great conference, wouldn't it? A 24-track conference. 24 sessions back to back. That's 24 hours of the day, and we're going to be going around the globe with some amazing speakers, so do check that out. One of the other things is the Rebel Labs Developer Productivity Report, which is a new report created, well, a bi-yearly report which Rebel Labs created. So Oleg, tell us a little bit about what the highlights are for that.
Yeah, so we surveyed more than 2,000 developers, Java developers, about the tools and technologies they use, and we got some really fascinating results. One of the biggest results we had is that IntelliJ IDEA has overcome Eclipse as the most popular IDE. We got some quite predictable results that Maven is not going anywhere anytime soon. It's still used in every out of 3 projects. Git has won the version control system where Spring is extremely dominant in the web framework space. we got other results about how people use containers and how popular is Docker. Do people use microservices, and if microservices make their lives and jobs easier, profilers, and so on and so on. So it's a great report. We took our time and put a lot of effort into making it beautiful. So you can check it out on the rebellabs.org, or I will be pasting the link to the RC channel. Well, right now. So just it's a really nice report. Go check it out to be on top of what is happening in the Java world.
Awesome. Thank you very much, Oleg. And yeah, I think the Spring Boot stuff interested me the most actually in that, because Spring Boot currently being used by 3 in 10 people, and if you're a microservice user, pretty much 1 in 2 people are using Spring Boot. So that escalated quickly, as it were. Without further ado, JUnit 5, next generation testing on the JVM. I'll pass over to Nicolai. Nicolai, I believe, has already shared his screen. There's Nicolai there, and here's Nicolai's screen. So over to you, Nicolai.
Hi, thanks. Welcome to the Virtual Jug. So we're talking about JUnit 5, and usually at this point in time I ask the audience who has used JUnit like the last month or the last week, or even today, and maybe Oleg can raise his hand. Maybe Oleg has used it today. I don't know.
I haven't, but I used it. I used it last week. So when it's only Mondays this week, it's Tuesday. But so I am almost qualifying.
Okay, cool. Yeah. So JUnit 4 is quite popular. I don't know. I didn't look at the report Oleg mentioned yet, but I guess if there's the most famous Java libraries ranking in there, then JUnit should be at the top, or at least like second place, maybe behind Log4j or something. So JUnit 4 is used a lot, and it's been a couple of years since the last update at all, and we're now going to talk about JUnit 5, which about which I'm going to tell you the rest of the session. So, as a heads up, we're talking about JUnit 5, which is work in progress. So there's no final release out. Actually, just last week there was the milestone 1. In November there was a prototype. In February there was alpha release, and milestone 1 was released in July. And that means that everything that I say could be wrong by the time milestone 2 comes out. It's not that likely, but it could happen. And also means that you can just give feedback and tell the JUnit team whether they're doing a great job, which I think they are, or which things they can do to make it even better. So we should really use this opportunity as a community to shape the tools that we're using. Here's a couple of links. I guess the slides will be up soon after the talk. The first, the GitHub repository and the user guide, which is really great. And the JUnit team has a Twitter account, which you can follow. And then I wrote a couple of articles on my blog. And now we can start with the basics. We're going to go over a couple of different things today. And these are the most easiest things to spot. And now I'm going to recruit some help. Well, maybe Simon. Simon, do you want to help me?
Sure, I can do my best.
Okay, do your best. Otherwise, you can hand over to Oleg. So what I'm going to show you now is this is a valid JUnit 5 test. This works. Mm-hmm. And something strange about it from a JUnit 4 perspective. So what's new? Can you spot it?
Is this the import? Missing import?
Oh, yeah, sorry. No, I should have put the imports in there, but this slides are too small. But something else is missing.
Let's have a look. So we have the app test on the method. I don't think the return or the parameters, I don't think there's anything different there. We have the assert true. Is that the difference, the parameter for assert true?
Oleg, can you jump in?
I can jump in, but honestly, so we have the test annotation that was present in JUnit 4, right? So
okay.
We can just annotate our methods, and they will run. We don't specify that this is the test class that has to be run as a test. So I guess that would be like a part of the external configuration.
Maybe the mean part is that the keyword I'm looking for is usually missing in slides anyway, because it just eats screen space. It's the public. You know, usually you have to declare everything public in JUnit 5 test. This is like the first thing that changed. It's very superficial, very small detail, but I like it right like this because it's, you know, it makes things simpler. Okay, what's new here? Do you want to try, or should I just go through it? Like, I give you like 3 seconds, otherwise I'll just blurb out the answer.
Good, Simon. You Your take on it?
I can't see.
Okay, guys, I'm not going to torture you anymore. So, yeah, usually if I do this in front of a couple of people, like somebody knows, but it's not like everybody knows. So, these are the lifecycle methods, and they used to be the annotations used to be slightly different. They used to be before each and before class and before, and now it's before all and before each. So the annotations have slightly different names. And then we have disabled here, which used to be ignored. So that's also renamed. And then we have this beauty, and I'm not sure whether it's immediately obvious, but this is not part of the public API. So disabled on Friday is not actually in the JUnit framework, albeit it's very useful, but we put it there. And the question is how, and we're going to answer that later. What's also new is that in assert equals, the message goes last, which I think is perfect. It always annoyed me that the message was in the beginning, so depending on whether I had a message or not, the arguments would jump around. So that's cool. And in case you have a really expensive message to construct, you can do it lazily with a Lambda, which is also the first nod to Java 8. This one is great. Many assertion libraries have it already. JUnit didn't out of the box until now. You can assert all, so you can put in a couple of assertions and be sure that JUnit tests them all and tells you whether each of them tells you the result. So it gathers the results from multiple assertions, and the result looks like this. So you get that each of these three, one part was wrong. Okay, so this is new as well. There used to be a test, and then you could put into the brackets, you could say I expected this or that exception. This was always a little bit unwieldy, and you never knew which operation precisely threw the exception. So with this, you can just go assert throws, and then you pass in the method under test as a Lambda expression. It's going to be evaluated by JUnit, and then it tests or asserts whether the exception is really the one that you're specifying here. So it would be exception dot. It should be a throw general exception or subtype of it. And then you can do that and get the exception back with except throws. So you can assert further details like the message. Okay, this one is really cool. With this one, you can have nested test classes, which was not possible out of the box before. There were a couple of runners that made it possible. We'll talk about runners as well later. But this one's really awesome because it makes it very easy to do this kind of behavior-driven testing style, where you have a new subclass, a new inner class for every new kind of state. We'll see in a minute what exactly I mean by that. So we could organize our tests in inner classes. And hand in hand with nested goes display name, which gives you the possibility to have your test properly named, like not the count test, but you say you can give it a nice name that reads better on the output. And nested and display name go hand in hand really well. So this is the output from the current IntelliJ runner. When I run the JUnit test, this is what I get. And you can see that on the outset, there's this testing a stack, which is the test class name, and then JUnit Jupyter, which is the runner. We'll talk about that later. But then come my tests. And they don't read like count test and this and that, or stack test, or whatever I want to call them. Now they read a stack when empty. After pushing an element, it is no longer empty. And if you want to go through the effort to actually specify all these names, then this reads really perfectly. Okay, this one is really new. Like the other ones should look more like incremental changes, but this is a first example of that really things change under the hood a lot. You can actually specify parameters, and you can. It's not obvious where my server would come from. Where would JUnit get an instance of my server from? We'll talk about that later too. Okay, to summarize the first part, we're already done with that. The lifecycle methods work much like before at different names, and many other details were slightly improved. You get nested and display name, which make an awesome couple to name your tests or structure your tests, and you get parameter injection. But we didn't see lambda so far. And if you remember, then JUnit 5 used to be called JUnit Lambda, the project, when it was very, very young, like last year. So where's the lambda coming? And we'll see that later too. And that's really nice, right? But the talk is called next generation testing, and this is hardly next generation testing. This is just a couple of nice details, but still only details. So nothing spectacular yet. And I have to admit I was a little distracted when we started. I don't know whether you said that, Simon, but you can ask question after each section. So whenever you have a question, just put them into any of the channels that were mentioned at the beginning, and then we're going to answer a couple that relate to the content that I just presented. So now we'll talk about the superficial changes. And are there already any questions, Oleg, that you?
Yeah, we got some questions already, actually. So the first one, talking about the changes in that you've made in JUnit 5. Are they backwards compatible with JUnit 4? So can you run JUnit 4 tests in against the JUnit 5 library?
So the question is yes, and the answer is yes and no. We're going to see later what exactly I mean by that. But let's say you can have JUnit 4 and JUnit 5 tests in the same code base and run them, and interoperability should be very well. But they're not, strictly speaking, compatible from a binary perspective.
Okay. Another question. I'm not sure who sent this question. Actually, maybe it was Oleg. Is the first failure? So basically, you have a chain of assertions. Will the first failure fail the entire chain of assertions, or will the later assertions run after the first fail?
The general mechanism in JUnit is to have an assertion test something and then throw an exception if that didn't work out. And this is still the way it's done now. So by default, the first assertion that fails the whole test. But you saw the assert all earlier. And that one actually allows you to give a couple of assertions as Lambda expressions, and they're going to be evaluated one by one, and then JUnit can actually execute one and get out the error if there was one, and then test the next and the next. So if you do assert all, then you can do what you asked for. Then you can get a comparison of all the things that went wrong or right.
Okay, awesome. We have another one, a question about which begs the question, why not use Spock? But I think that's better left till the end. Perhaps that's a more general question.
Yeah.
Okay, that's everything we had. Sorry to interrupt, but just a quick shout out as well to a group that are watching live, the Pennsylvania State University Administrative Information Services, which is a great name. It just rolls off the tongue. But they're hosting a room for attendees in the central Pennsylvania area. So hello to everyone there. Hello to Steve Moyer. Thank you very much for setting that up. And sorry for the interruption. Back over to you.
No, don't worry. Hi, Pennsylvania. Okay, so we're at the basics. Let's cover one thing that's pretty new. That actually went into the code base like 2 weeks before the milestone came out, more or less. So, oh, sorry. No. Don't get confused. Wait a moment. I'm very sorry. There we go. Okay. So, in JUnit 3, you had a test suite, which was a little different from the way you declare tests usually. But usually, you used to declare tests by having a method called test something, and then JUnit 3 would find them and execute them eventually. In JUnit 4, we got annotations, so we could just put add test on any method, and then JUnit 4 would find them and then execute them. And the same is true with JUnit 5. But all of these have in common that the tests had to be defined at compile time. You write the test as a method, and it is present at compile time. And that, at first hand, doesn't sound so bad. But there are some things that people want to do that are not going well with that. For example, you might want to create tests with Lambda expressions. Or you want to say, I have a bunch of parameters, and I want to run the test for each of the parameters. Or maybe you want to even parse non-source files, maybe files that testing department or some other people in your company put together, and you just want to run them. And then you're pretty quickly in a situation where you have to generate tests at runtime, for which JUnit 4 especially, and JUnit 3 only very limited, had no real support. It was possible, it was really hard to do so. You had to interact on a very deep level with JUnit. So what we'd like to do instead is we would like to have a real feature to define tests at runtime. And this is exactly where dynamic tests come in. So with the dynamic test, you now have the chance to do, say, this is to define at runtime the test that you want to run, and JUnit will just execute them like any other test. So a dynamic test is very, very simple. It's just an instance of dynamic test that is wrapped, that wraps a test, and that has a name and executable, and then other methods annotated with test factory are going to create those dynamic tests. So this is how it works. This is a JUnit 5 method that executes perfectly fine, and the first thing you see that I don't have an add test, but an add test factory annotation. And then it returns something, namely a list of dynamic tests. And now we just have to create them. And what we do here is we use the dynamic test factory method, also called dynamic test, and we give it a name, either grade test for point or another grade test for point, and then we can specify the test that we want to execute as a Lambda expression. Then we put these two tests in a list and return it. And when JUnit scans the file for add test annotations, it will also find add test factory annotations, execute the method immediately, find the tests that are in there, and use them to populate the test plan, and then execute it eventually. So this is what I just said. JUnit detects them, generates the tests, puts them into a test tree, and runs them. So I mentioned lambdas. I said it was called JUnit Lambda, and it might be want to use Lambda expressions to create tests and all that kind of stuff. And this is what actually people would, I think, would really find great if this would work. I mean, what's written there doesn't even compile. It's not even valid Java code. But to get somewhere close to that, to be able to lose the boilerplate, the void. I mean, we already lost the public, but void, and then the brackets for no parameters that we're never going to have anyway, and to get rid of that. And with dynamic tests, you can actually come close. It's not quite like this, but you can come close. So what we first do, we create a class. So now we want to go here. We want to go here. This is our goal. We want to have the possibility to write code that looks as much like this as possible. And we want to use the dynamic test feature for this, because obviously Lambda expressions are going to be evaluated at runtime. So we need dynamic tests to do this. So what we do is we create a class called Lambda Test. And then we create this cool method called Lambda, which you should never do in any code base, unless you're a Java slang guy. But otherwise, don't do this. And you can just put in a method, and you just give it a name and the executable, and it puts this dynamic test that it creates from this into a list. And then later, when JUnit comes by, it just returns this list. So this part is really easy. So now we want to call this Lambda method. So our test, let's say we want to test points, we have some point class and want to test it. Our test class extends the Lambda test. And this is really hacky already. So I want to go into this defining test with Lambda expressions. We have to go off the road a little bit. So we use double brace initialization, which means that basically it means that the code that is in there will be executed immediately. So to keep things simple, let's not go into too much detail. This is also valid Java code, and will do what we expect to do, what we expect it to do. If we give this class to JUnit, it will call Lambda, it will populate the dynamic test list, and will run this test later. So
I know that's valid Java code, but I mean, is it recommended to do that, would you say? I know there are many people that would say it's not.
Yes, so okay, let me go into detail. So double brace initialization, what it means is that you get an anonymous subclass that executes the code that you put in there in its constructor. And in production code, this has a huge disadvantage, because this inner class, it's an anonymous inner class, and it gets a reference to the outer class. And that can mean all kind of bad things. You can actually hold on references to huge objects, which will then not get garbage collected, all that kind of stuff. So in production code, I would definitely avoid this. In test code, which is only going to run shortly, I think the drawbacks are not that dominating. But still, yeah, it's a matter of style, actually. I don't mind having my IDE generate the void and everything else that I need to put in for a test method. But if you do mind and you want to do something really crazy, then yeah, you can do this and it works. I mean, it's not like something bad's going to happen.
Mm-hmm.
But you can ask me again after this one whether you want to do this, because this is even crazier. So what you can do is you can actually use reflection to find the name of a parameter, of a method parameter, but also of a lambda expression parameter. So what we can do here, we can actually use a grade test for point, which goes in as the input parameter of a lambda expression. Then inside the code, with test code, we can use it or not, but it doesn't even matter. The string, the variable itself is not important to us. We just use it to later reflect on it and then get the name out. So this is really weird, but it also works. And with this, you're already really pretty close to where we wanted to get. And as I said earlier, whether that's worth it, I would say no. I think this is too hacky, but it's fun to go there and try this out and see how far dynamic tests can get us. Okay, but let's get back down to earth. So lambda tests are nice, but what we really want to do is we want to use dynamic tests to create parameterized tests. We want to be, it should be easy to say we have a method that says it's called point test and tests a single point, and we want to pass in dozens of points to make it test a lot of different scenarios. The problem is if we do that in a regular for loop, which would be the easiest, we just create a bunch of points, we loop over the method, and then use that as our test. Then we have the disadvantage that as soon as the first point fails, the whole test method aborts. And neither JUnit nor any other tool actually knows that we have created several tests. To all of these tools, it looks like one test, which apparently loops over something, but JUnit doesn't know that. And that means that tool support is generally worse than it should be, which is also one of the reasons why it's so hard with JUnit 4 to do this kind of test. You have the parameterized JUnit, which is a nice runner actually, which does this pretty well. You have theories. You have one other feature that I forgot. So there are a lot of competing ways to do this because it's not easy to do it. And with JUnit 5, this can get much easier. So now we have this method point test, and when we want to test it for a bunch of points, what we do is we create a bunch of tests. We create one test for each point. So here we create a stream of some points, and then we map each point to a test which tests that precise point. And because it's annotated with test factory, JUnit will see it, will create all the dynamic tests, and will run each of them individually. And each of them will be like almost, there are a couple of details that are not yet implemented, but in general they can be as integrated into the regular life cycle as any other test that you write at compile time, which I think is really great to have this kind of support. There's a different constructor for the same thing. This is basically the same example again. We use a different way to create it with dynamic test.stream, but as I said, it does the same thing. Now let's say you have someone who creates points from as a service. He creates them and dumps them into a file, or somebody in your company creates test cases and they're very repetitive. It's always the same. It's just 2 points and the distance between them, and you want to do it like 1,000 times. You're not going to do this in your code, right? You're not going to have code that has like 1,000 points in there. That's totally ridiculous way to test these kind of things. What you could do instead, you could put them into a file, and it's very easy now to have one test per line in the file. This is all you need to do. You just stream the lines in the file. You parse each individual point. You map each point to a dynamic test, which tests this point, and you're done. And you can have somebody externally create these test cases if you want to. Okay, that was dynamic tests already. So we saw that with text factory and with dynamic test, you can create tests at runtime. And we saw that finally we can use lambdas. Yay, it's totally awesome and totally worth all the hacking, who knows. But you can also use it for sets of parameters and for external input. So again, this is cool, but not quite next generation testing, right? And whenever this question pops up, then it's your time to ask questions, Oleg or Simon. Preferably if there were any for dynamic tests already, but I guess that was too short, right?
Yes, we don't actually have any questions on this section right now. If anyone has any questions, no, we do have a question. Just as I say that, see, so I always tempt fate. A question from eJam. Let me see. I guess this is the question about when are dynamic tests good. What's their application from eJAN?
What's the application? Yeah, basically what it says on the slide. So you can use, you have a test method and you want to say, or maybe in your theories. If you use theories, then the idea is that you have a whole test class that tests one coherent theory for a lot of different data sets. And if you're in that scenario, and you're often in that scenario, to say, like, especially if you do something that's very close to math, then you might be in the case where you want to test the same thing for huge amounts of data. Not huge, I mean not big data kind of huge, but for more than you want to write in a source file. So what you want to do is you want to have the whole battery of tests run against each of these data sets. But if you get down to the method level, it gets much more complicated in JUnit 4. If you want to say that I have this method which tests the distance between points, so I need 2 points and a distance as input. And then you have this other test method which tests whether I can add 2 points, so you need 2 points as an input to add, and a third point to validate whether the result is correct. So if each method takes a lot of different kind of parameters, then doing the JUnit 4 way is complicated and hard and doesn't work that well. So here you can do this very easily. You can, on a method level, decide, I want to have a method which just tests the point, and I want to create another method which tells JUnit to create a test for each of those calls. And you can do it on a very fine-grained level. For another method which tests point distance, you have another factory, and you create that other set of tests. I hope that answered his questions.
Yeah, and I guess from a maintenance point of view as well, that must be pretty useful, because obviously if you do have a huge amount of tests based on huge amounts of data, you don't want to have to kind of check all your tests in and then constantly update them, whereas it can just be generated live on the runtime. You don't have to keep maintaining them.
Yeah, and if you do it the simple way and just go with a loop, which is always possible, you can do like what I said earlier, like here. You can do the same thing. Here with a loop, you can just loop through the lines in the file and do the same thing basically, but then you get one test only. And if the third line fails, you'll never find out what happened with the other 1,000 lines.
Mm-hmm. Okay, and actually a more general question. Actually, let's do a quick follow-up question from eJAN first. Is it fair to say dynamic tests are primarily a new way to do data-driven tests?
It sounds fair to me. Yeah.
Okay. One question from M. Furlivas. One of my struggles has been with concurrency tests. Are there any enhancements to unit test these types of scenarios?
No, and not that I know of, at least.
Okay.
Nothing comes to mind. And actually, to make matters a little bit worse, the extension mechanism lacks one feature which you could do in JUnit 4. In JUnit 4, you could have a rule, for example, that execute each test on a specific thread, for example, on the event dispatch thread in Swing, which was quite common. If you want to test UI, you have to do on the event dispatch thread. So you can make a rule, and they dump each test method on that thread. That specifically is not yet possible in JUnit 5, but I assume they work on fixing that.
Okay. A couple more questions actually. One from JTT Kim. Actually, what I'm going to do, that's quite a generic question. I'm going to leave that one in IRC. So if people have best practices about how to manage their directory trees about their tests, please do reply to JTT Kim in IRC. One question I do want to ask you, Nicolai, live though, is a good question from MXSB or Max. How do I handle the expected results in terms of parameterized tests?
Yeah, I glossed this over so it fits on the slide. If you go to my blog, you actually see that I do something slightly different. In this case, point test isn't really that great, right? Because it just gets a point. It cannot test that much. So if I want to test, for example, the distance between 2 points, I would of course have to pass in the expected result as well. So if I don't pass in the expected results, then I have no way to actually use a normal assertion to do that, to validate my my code. So yes, you would. In this case, for example, you would likely not stream lines of points, but lines, and each line on the file has like a point, and a distance, and then I pass it to a method that says test point distance. And it takes these 2 points, computes the distance, and asserts it's the same one as the one I passed in. So I guess in many cases, if you base it on data, you have to put in you have to put in the results as well, quite often. But that's basically every time when you write a test case right now, and the assertion is something that has a value in it that you know because you put in you just constructed the 2 points so that the distance is 3, and then you assert that the distance is 3. In that case, you put in the 3 because you know it's the right result. In that case, that would have to be a parameter to the method. Mm-hmm. If you can assert something else, which is not the sort of value that you yourself put in, then you don't need it specified as the test input.
Okay, and we'll do one more question actually before we move on, because I want to make sure that we get through other content as well. MJ Treff, how about a dynamic test where you perform the same test against a number of different classes through reflection? For example, let's say I want to guarantee that all extensions of object X pass test Y. Would that be a good use of dynamic testing?
Okay, well, it's a good use. Let's take it from a technical perspective first. What I would do is I would create a method that gets this class and that gets one class and verifies that it has the properties I want to have, and then I create a test factory method which looks for all the inheriting classes and creates a dynamic test for each individual one. That would be pretty cool actually, because then I get a test for A class and B class, and C class, and when only B class fails, like all the other ones are still tested. Now, whether you actually want to do that, well, why not? I mean, that's a good way, for example, to test equals and hashcode contract. You can do that, maybe, or I guess there might be use cases for that, and in that case, that would be a good application, I think, yeah. Better than looping every day of the week.
Okay, I lied. One more question from Nicolai. Does JUnit 5 also work with Java 6 and 7?
Not as it stands right now. At the moment, JUnit 5 uses Lambda features in it. Lambda features, sure. So lambdas and streams inside its own code base. And I think it's very unlikely that we're going to backport it. But that's no official statement that I know of. Maybe they do. Interesting
decision. Interestingly, again, we can refer to a stat on Rebel Labs which says, I think from memory, 62% of people are using Java 8 in production. So I guess that's a good number, but I guess still alienating 38% of groups with Java 7 or below. Okay, great. Thank you very much. Straight on to more content now.
Yeah, sure. So we talked about some basics and how we can use dynamic tests. What's also very interesting is how can we extend JUnit? How can we make it do our bidding? And you guys still there? Because I don't see my slides in Hangouts anymore.
Yeah, no, we're still here. Everyone can see the slides. It's not so much what you can see; it's what I can see right now for the attendees. So that's cool. Don't worry about that.
Okay, cool. Sorry then. So in JUnit 4, what did you do? When 4.0 came out, and you want to extend JUnit and do something that don't do out of the box, you created a runner. And a runner, you could do everything. And you also had to do everything, which means that it was kind of heavyweight, and it was also exclusive. This is the major drawback. You could not have two runners on the same test class. So that didn't go so well. So the JUnit team decided in 4.7, if I remember correctly, to add rules. So rules were composable. You could have several of them. And rules would usually do something with, like before and after each test. This is not all in detail. This is not correct. You could also put in other methods, you could also wrap other behavior, not only tests. And you could also put them on a different thread. But by and large, this is what you could do. You could do something before and you could do something after each test. And it's great, right? Now you have two extension models. Both have limitations. They have a considerable overlap, which makes it not that easy to decide which way is the way to go. And composition, apparently composition caused problems. So the JUnit 4 extension model is good, otherwise it wouldn't have survived so long, but it has room for improvement. And this is what the JUnit 5 team set out to do. And they have a couple of core principles, and one of them is literally prefer extension points over features. So JUnit 5 has extension points. This is all of them, and we're not going to have a test about it, so you don't have to go through them and try to memorize all of them. But if you just glimpse at the list, you can see a couple of things that we recognize. There's this before all, before each, which sounds a lot like lifecycle methods. We saw the my server as a parameter earlier, and there's a parameter resolver here, so maybe that has something to do with that. And then you have to do something exception handling, and it looks like there's extension points for a lot of things that we might want to do. But what is an extension point? An extension point is an interface. And the interface is usually very simple, often only one, maybe two methods. And it's pretty straightforward what they do. So when JUnit comes to this extension point, so when JUnit comes to before each, then it grabs everything that it can see, like the test method's name and the parameters and the annotations and the class and everything basically that is in there that might be useful information to your extension, puts it all into a test extension context and hands it to your method. Sorry, hands it to your implementation. Hands it to your implementation of the before each callback. And if you want to implement an extension, you can have a bunch of these extension points and implement all of them at once, and then your behavior at this way you can put your behavior together and have at the different extension points have JUnit interact with you or with your class. So let's do an example. Let's say we want to benchmark our tests. So what we want to do is, for each test, we want to just write the elapsed time to the console. This is very simple, nothing fancy going on. And if you think about it a little bit more technical, you might put down these 2 points. Before test execution, store the test launch time. And after test execution, print the elapsed time. And, crazy coincidence, before test execution, after test execution are actually extension points. Hi there. So this is our benchmark extension, and implements the before test execution callback and the after test execution callback as a field where we can want to store the launch time. And now this becomes pretty straightforward. We implement the before test execution method, and we just call system what? System current time release? Is there something between there? No, it's system current time release. You call it and assign it to the launch time. And then after the test execution, you call it again, subtract the launch time, and print it to the console. So as I said, that's pretty trivial. So let's see other examples. Remember the disabled on Friday? So you can finally get out of work without this pesky tests keeping you there. Let's see how we can do that. So there's a test execution condition. That's an interface that represents an extension point. And we can just extend it, and then we get this one method we have to implement, which is called evaluate. Again, JUnit gathers everything that's in the test that might be of interest to us and hands it to us. And then we just, basically in this case, ignore all of the context because we just test whether it's Friday or not. And if it is, return the condition evaluation result that we get from the disabled factory method. And if it's not Friday, then we return enabled, and you got to fix the test. So that was also pretty easy. The next one is much more complicated either. So we want to do parameter injection. In this case, we have the idea that we want to somehow inject our servers, or my server, into this test. So what we do is we implement the parameter resolver extension point. And here we have two methods. The first one is supports, and the second one is resolve. The first one is when JUnit asks us, it finds the parameter and says, what is this? This is my server. So it puts all the context into it puts everything it finds into the parameter context and goes to our extension and says, look, I found this. Can you do something with this? In this case, we just check, is the type of the parameter my server? And if it is, we just say, yes, I support this, I can do something with it. Then later on, JUnit will ask me to resolve this specific parameter. And then we just, in this case, return a new instance of my server. So with this cooperation between supports and resolve, we kind of simulate type safety, so to speak, because from JUnit's perspective, everything's an object, so it has to ask us first, can you do this? And if we say yes, then we're asked to actually do it later. Okay, now we want a bunch of extensions, but how do we apply them? How do we tell JUnit that this extension is there and that it should use it? And we can do this. This is the regular mechanism to do that. You can say extend with, and then you just give it your class. And then JUnit will see that if it runs the JUnit 5 test, it has to instantiate an instance of disabled on Friday condition and pass all kinds of call it at all times where it might apply. But this is very technical and verbose. It doesn't look nice. I mean, it's hardly readable at all, and sort of boilerplate on there. So we can do better, because JUnit 5 uses meta annotations a lot. So meta annotations mean you can put annotations on other annotations on other annotations. And JUnit knows about this. So whenever it finds a method, for example, it goes through all the annotations it has, and those annotations, and so forth. So it collects all the annotations that are on there, and it uses all of them to decide what's going on. So that means that we can create meta annotations and have JUnit properly evaluate it. Also, this is my experiment of how often I can put the word annotations on the same slide. So here we go. We have the disabled on Friday condition, and we have to use it. Normally, we have to put extend with disabled on Friday condition class on the test method or on the test class. Instead of doing that, we do something else. We declare an interface which is called disabled on Friday. Sorry, not interface, an annotation which is called disabled on Friday, and we annotate it with its own extension. And we can do something similar for integration test. We want to have an annotation integration test, and we want it to be a test. We want to tag it. That's a JUnit feature we're not going to cover today. And because integration tests are always slow, we want to benchmark them, and we want to pass in the server, because this is what most integration tests do, right? They reach out to our server and do something with it. So now we have two annotations, disabled on Friday integration test. And when we slap them onto a method, then JUnit finds these annotations and goes looking for meta annotations, and will eventually find that yes, this is a test, it's tagged integration, and has 3 extensions applied to it. And then when it runs the test, it will go to all the extension points and pass and call each of our extension at the correct point in time. So this is already all there is to say, not all, but most of what is to say about extension points. We actually left out a couple of details. But this is the gist, and you see that it's fairly easy to create extension points, and that they're also pretty flexible. They compose very well, and you can have a nice way to use meta annotations to make it very readable and to customize your own test extensions to look actually beautiful inside the code base. As I said earlier, when I answered the question about the threading, these are not exhaustive yet. So there are some things that you cannot do with them. Particularly, you cannot do much with threads here, because JUnit is not handing you over the power to go to another thread, at least not yet. There are other things, for example, the dynamic tests generation, you cannot interact with that yet. And in general, you cannot interact with the test plan. So when JUnit builds the test plan, you have no way to have an extension point manipulate that test plan. And there are discussions around all of these issues, and some of them might come to fruition and be implemented and or fixed, and others might not. So this is one of the points where you can actually influence where the project goes. You can look into your code base and see what would I want to do with JUnit 5, where does it help me, where did JUnit 4 not help me, how can this be better, and then pass this on to the JUnit team as GitHub issues and ask them to ask them to come up with a solution if they can. So this is really cool. And this might be next generation testing for Java, maybe. But it's called next generation testing on the JVM, so there's more way to go. But as before, let's have some questions if there are any.
Okay, sorry, it took me a while to find the window to unmute. Here we go. So a couple of questions. From Jara says, can you have multiple parameters first?
Yes.
You can. That was nice
Yes.
and easy. Luigi, how can you manage your parameter lifecycle? Like, for instance, if you were shutting down the server?
Good question. Not yet, I'd say. So, oh no, wait, that's not right. You have an extension point for after the test. So I would guess you had to do it manually. There's no way to have to register, for example, callback and say, JUnit, look, if you're done with the test, do this and that with a parameter. For now, you'd have to do that yourself. You would have to register another extension point. You would have to store the instance that you created, and then when you call after the test, you have to find the right instance and shut it down. But actually, the idea to register a callback maybe is not that bad. Maybe we should create an issue for that.
Okay. Sounds great. That'd be good feedback. Question from Panshul G. Do you think it would be a good idea to use parameter extension for providing mock data?
The JUnit team surely thinks so. So one of the first demonstrations of this extension API was actually a Mockito extension, which would mock whatever parameter you put there. And this also connects to the first questions where you can have more than one parameter. Because if you do, you immediately think about, okay, now I have a lot of them, and each extension applies to each. That's strange. I mean, for example, let's say two extensions both want to provide me with strings. How do they battle it out? Which one gets to create the string? The same is true with mocks. I mean, maybe I want to mock some of the parameters, but not all of them. So what you can do, you can annotate the parameters themselves, for example. You can find other ways to do it, but the interesting part is that, as I said earlier, JUnit is gathering all the information it can get and gives it to you so you can evaluate whether you want to do something at that point. For an extension, that means it collects the parameters type and also the annotations on the parameter, and you can query that. And the idea of the Mockito extension that the JUnit 5 team wrote, just a prototype to show the power of the API. What they wrote is you write an add mock annotation in front of the parameter, and they look for that. So they're saying I support basically every type, but to create an instance, I want to be sure that I'm in charge. So it looks for the add mock annotation, and only if that's there, then it creates an instance, or then mocks an instance.
Okay. Follow-up question from Luigi. Actually, I'm not sure if you covered this in the previous answer. So do you have a way to reference the parameter outside of the test itself?
Well, that would depends on which side you're on, right? If you're inside the test method, then I guess the questions wouldn't make much sense, because when in the test method you get the parameter passed in. Then outside the test method, of course, you can. So I guess he means the other side. So when I'm writing the extension, that applies what I said earlier. If you're inside, you get called with resolve, and then you return it at the end of the method. So you would have to store it someplace to come back to it later.
Okay, perfect. And that's all the questions we have. So back over to you.
Sure. So we're pretty close to the end. So we better come up with that next generation thing. Let's talk about the architecture. So for now, we talked about JUnit 5 and what we as programmers, or how we as programmers can use it to make our life better. Now, architecture covers the innards of JUnit and how the developers of JUnit want to make their own lives better, and coincidentally also improved ours. So JUnit 4 has something which, if you want to be mean, cannot even be called an architecture, at least on a modular level. Like if you talk about jars, then there is no architecture. You have one bubble, JUnit 4, and then on the side there's this Hemcrest thing hanging on, but otherwise it's just one jar. You want to write tests, you use that jar. You want to write an extension, you use the same jar. You are an IDE or build tool, and you want to provide tooling, you use the same jar. Everybody uses the same jar. And this is not the best way to separate concerns, obviously. And it had some actual drawbacks. So our tools provide us with a lot of interesting features. Especially JUnit integration is very good. But the API of JUnit was not powerful enough for that. So if you're a tool developer and you want to get ahead, or if your users bug you to do this or that with JUnit, what do you do if the API doesn't do it? No problem, I'll use your flagship. That will make everything better. And that was done. And that meant that nothing was really safe. So the tools would call private methods. They would even reflect on private fields to get the state of JUnit. And they used all this to help us with the features we wanted. So they didn't do this on selfish or devilish reasons. But still, that meant that some tools are bound to implementation details. And that meant from the JUnit team perspective that they had a lot of trouble maintaining the project. Because imagine refactoring code when some guy out there might be depending on the variable name. And that led to maintenance a lot harder. And I think Johannes Link put that very well. He was one of the initiators of the JUnit Lambda project, which led to JUnit 5. And he said the success of JUnit as a platform prevents the development of JUnit as a tool. So the platform meaning the de facto standard where every IDE and every build tool supports. If you create a new tool, I guess the first testing framework you want to support is JUnit, because it gets you the most developers. So this was JUnit platform. It was extremely successful. JUnit as the tool was also successful, but it was really hard to develop it, maintain it further because of this tight integration between the two parts. So JUnit 5 set out to change this. The idea was that we separate those concerns we had earlier. We have us developers who want to write an API. Who want tests against an API. We have a mechanism that discovers and runs tests. And then we have an API for tools to use that. So this looks like three different things that we want to do. And if you look at it even more closely, then you can come up with maybe even more than one mechanism. So this touches as well on the JUnit 4 and JUnit 5 question we had earlier. Maybe I don't want to have only one mechanism that discovers and runs tests. Maybe I want to have one engine for each variant of tests, for JUnit 4 or 5 or test in G, or I don't know, maybe I want to write tests in natural language. So whatever suits you, maybe you want to have an engine for that kind of test. And then of course, if you have several engines, you somehow have to orchestrate them. And because, you know, Java, you had to have an API. But in this case, it makes a lot of sense. So you want to have each engine implement an interface to make sure that the engines are interchangeable from the outside. The API that uses the tools to run tests, that the tools use to run tests, that is there and stable and can use this engine. Can use the engines no matter how exactly they're implemented. So JUnit 5 is actually more than just one jar. JUnit 5 is more than just one project. It's split into sub-projects, and each of them has a couple of jars. This also means, if you look at the artifact names, that if you go to Maven and search for JUnit 5 right now, you will find none of these, which is, from a marketing perspective, maybe not the best decision. So JUnit got split up into different sub-projects and modules. And we'll talk immediately in a moment what they mean. But these are the artifact names, and they're in different versions. You see the Jupyter up there, which we already saw earlier already, and then platform down there. And so let's see what exactly that means. So this is what we want to do. We're at the top of writing our tests. We have the JUnit Jupyter API. So the API that I showed you in the first couple of slides, they are part of this JUnit Jupyter sub-project. And now we want to run them. Maybe we want to run them with Maven or with IntelliJ, because apparently nobody uses Great Raw Eclipse, I heard earlier. So now these tools, what do they want to do? Earlier they would call de facto the same jar, the JUnit 4 jar, which would do everything else for them. But now they do something different. Now they call into the platform and say to the runner, look, I was told to run all tests in this directory, let's say. I was told to run all tests in this directory. You do that now. So they give this to the JUnit platform runner. The runner looks for engines that have been registered. So there is this JUnit platform engine interface. Or it's not just a single interface, it's an API, it's a couple of interfaces. And the JUnit Jupyter engine implements that. So the runner treats all engines the same. The engines register themselves with the runner at the beginning. So when you launch JUnit, each engine will go to the service loader and say, look, I'm here. If you need an engine, call me. And then the runner will pick all the engines and tell them to just run tests. Look for your test particularly. So the way it looks now, it would be if we would just have JUnit 5 tests, or to be precise, JUnit Jupyter tests. And this is cool. There's a clear separation of concerns. It's a nice architecture, API for us, an API for tools. But again, this is not how is this next generation. It's just an implementation detail. Why do we even care? But we do. This is the point. This is what I think is maybe the coolest thing about JUnit 5, besides the Lambda hacking at the beginning, because it opens up the platform. The success of JUnit as a platform can become available to other testing tools as well. And this is how. You want to run JUnit 4 tests? Don't worry, you just create an engine for it. You want to have test in G, you want to have the same support, you run test in G to run as good as well supported as JUnit, you take an engine for that, or you implement an engine for that. Or I said earlier with the natural languages or whatever you can come up with, Cucumber or whatever. If you want to have a different testing framework and you want to make sure you get the same level of support from your IDE and your build tools, all you need now is an engine for that, which might not be trivial, but at least it's manageable. And this is how it looks. So you have the JUnit 4 artifact in there, and then you have the JUnit vintage engine, which exists already and runs JUnit 4 and JUnit 3 tests. And then the right part, just to make it perfectly clear, is absolutely made up. There is no test-ng integration whatsoever. But it's my poster boy example. You could do that. You could have a test-ng engine, implement the JUnit platform engine API, and then the JUnit platform runner wouldn't care, and neither would all your tools. To them, it would just be the same, whether they're on JUnit 5 or JUnit 4 or test-ng or Cucumber or anything else. So this means that once JUnit 5 is really getting adopted, that the tools can finally decouple themselves from implementation details. And they can support all frameworks equally well. Well, not quite equally, but almost. So it's whether JUnit can reach like 100%, the JUnit API can reach 100% of what the tools want to do, is not entirely sure, but at least we have a far higher percentage than with JUnit 4. And you can actually plug other frameworks in there. So that means that a new framework can start with full tool support. If I create a new crazy testing framework that I want people to use, earlier I had to convince them to use it, and then they would also have to go through the trouble of integrating with their tools. Now they don't have to anymore. If I provide them with a JUnit 5 engine, sorry, we have to say now a JUnit platform engine, then that would mean that I can just give them my cool new test framework and the JUnit engine to run it with, and then they can get almost full tool support out of the box for IDEs, for build tools, for whatever. And that means that developers can try out new things way quicker in this area than they could before. And this is what I think why this might actually herald a new generation of testing frameworks. It might be the case that in a couple of years there will be much more of them, because now it's so much easier to get developers to actually use them, not just in a hobby project, but for real. So, to put it more succinctly, JUnit success as a platform can become available to everybody, and this might herald next generation testing. So this is why I'm so convinced that JUnit, or I hope at least, that JUnit 5 will considerably improve all of our testing, not just those people that use JUnit, but everybody's testing experience anywhere on the JVM. Whew. So, we saw that the architecture separates these concerns, that we have different APIs for the different tasks that we want to do, for writing code, for running the tests and inspecting the results. And this is also true for new frameworks. This opens up the platform, and this means that we get tool support for everybody. And again, there's even more to the story, a couple of details we have to leave out. Cool, that was the architecture part. Simon, Oleg, any questions?
So I don't see any questions at the minute. I've just pinged in RC, so no, I think we can carry on.
Okay, we gotta let them catch up.
That's true, yeah. I pinged. Oh, here we go. When would you use in a class like test case as mentioned at the start of the session?
Sorry?
When would we use in a class like test case as mentioned at the start of the session?
Is this the nested annotation that?
Might be, yeah, it could be, or it could be the double double brace, maybe, I don't know.
Okay, so whether you want to use nested or not, I think it's kind of like if you never wanted to use it before, you're probably not going to benefit that much from it, because it depends on how you write tests, right? Some people write these behavior-driven tests. I usually don't, I have to say. So I didn't come up a lot against the case that I really want to structure my tests in inner classes. Other people might. So it's a help for them. What I actually do is, when I create an interface, I like to create a test that should be executed, so a couple of tests. So I write a test class, an abstract test class, that I think each implementation of the interface should pass. So how do I do that then? Then I create a test for the actual class, and then I extend that abstract interface test class, and usually all I have to do is provide an instance or two, or depending on some configuration details. The point is, if I want to test more than that, then I mix the test that I inherited with the test that I write manually. And if I implement 2 interfaces, I can't do this twice because I can only inherit from one class. So in this case, is why I use nested classes every now and then. I have 5 interfaces that I implement. Each of them has an abstract test class. I have 5 nested classes, and each of them says, look, I'm here to verify that that contract is working, and I'm here to verify that that contract is working. And then maybe have a couple of additional tests to verify that things go well together. I go quickly to tool support because that's a short and important part, and then maybe people have caught up with the architecture and are ready for more questions. Okay. So now you want to start, right? So I guess you want to start now. So what do you want to do? For writing tests, it's really easy. You just add this one artifact. And this is the API. It's very slim. It's just a couple of interfaces and annotations and classes, and there you go. You can start writing tests. Now, in case you actually want to run tests, then it gets a little bit more complicated. So let's first talk about native support. So native support would mean that each of the tools that are listed here are natively supporting JUnit 5 without anything else you have to do. So Maven, there's an issue, but nothing seems to happen, at least not that I can see. I didn't find an issue in Gradle. IntelliJ, since, I don't know, like last week, has early access support in the newest version, which totally rocks. It seems to work fine. I didn't test all the nooks and crannies, but it seems to work quite well. And then in Eclipse, there is an issue as well as in the JUnit bug tracker and in the Eclipse bug tracker, and this seems to be some slow progress. But to make things clear, this is not going to happen this year anyway, so I guess JUnit will have another milestone or 2 before the end of the year, and then around next year maybe there's a final general availability release, and I guess support will be there by then. So I'm not worrying. Okay, I'll let you stare at the slide for the moment because we had some trouble setting things up, and I got to quickly get the cable to recharge my laptop. So I'll be back in a minute. Stare at the slide.
So Oleg, let's put you on the spot here while we wait. Let's have you describe the slide, Oleg.
Oh look, it was closer than I thought, but still, Oleg, go.
Sorry, that would have been funny. Yeah, go for it, Oleg.
Sorry, I think I blacked out for a second.
So this is kind of mobbing going on between you two. Do I get this right?
Oh, we love each other dearly.
Say it for yourself.
So, sorry, I didn't want to get in the middle of that. So, I talk. You can fight this out between the two of you. So, what we can do here is, let's say we want to run our tests, and the tool support is not yet there. So, what we can do is we can go the other way. I said earlier that you can use JUnit 5 to run JUnit 4, but you can also do it the other way. So, in JUnit 4, you have runners, right? You remember. And there actually is a JUnit 5 runner. That means that you can create a normal JUnit 5 test class. Then you use the JUnit 5 annotations and syntax and everything. And then you annotate it with run with JUnit 5 class. And then you run it as part of a JUnit 4 test run. So then you just say Maven test. Maven uses JUnit 4. It comes by this this test class. It says, hey, wow, this is a public class, and it has a run. It has a it looks like a JUnit 4 test because it's a run with in the beginning. So I'll use that runner to run it, and that runner implements all the JUnit 5 stuff. And if you don't want to put this on each individual class, you can use the packages annotation, which I think changed to select packages. Did I not update the slide? It should have. Sorry, I think it's select packages since milestone 1. So you can put in package names there, and it interprets them hierarchically. So whatever is below my test package also gets executed. So this is what I do. I just have one of these classes somewhere in my test suite, and it says packages or codefx whatever, and then JUnit 4 just runs all the tests. Interestingly enough, until in the alpha release, that was a pretty good way to do it. But from alpha to milestone 1, they generalized a couple of concepts, which meant that now IDEs have far more trouble connecting the information they find in JUnit they get back from this run with what they find in the code files. You can still use it to run the tests, but before you could actually also see, click on the test class in the test tree, and it would go to the proper class, and at least JUnit doesn't work anymore. So we're now on the brink of that. I say this JUnit 4 detour is kind of maybe not the best way to go anymore. It used to be in the alpha version, I'd say. Okay, for the build tools, you actually have a very elementary Gradle plugin and Maven Surefire provider. Both of them were created by the JUnit 5 team. Both more of like proof of concepts, and they hope that the respective teams will take them over soon. And the user guide contains some details about how to use them. But they do what you want to do basically. So you can just go Maven test, and it does what you expect it to do. And if all of that is too fancy and you don't care about tools and IDEs and all that kind of stuff, you're more like a Vim kind of guy, you can use the console runner. Sorry, it's now called a console launcher, to not confuse it with the runners. And yeah, this is pretty much what you want to have to do. You download it. There's a script in there, and you just point the script to the compile test class and say -a to run all the tests, and then maybe you want to specify a specific test, and then just runs that. And the beauty of the console launcher is that it's pretty complete. It understands JUnit 5 already pretty well. It has nice, colorful output, and it works okay. And you can integrate it into your tools of choice because the return value indicates whether something went wrong. So if you already want to use JUnit 5 and none of the other support suffices, maybe you can just get by with calling this from on the terminal. Oh, sorry, on the console, and get back the result or the return value and say whether anything failed or it didn't. But I'd say that the console launcher is more like to try things out now, and it will go away surely when tool support suffices. Okay, to summarize the tools and setup, you can start writing tests right now. IntelliJ already has native support, but if you want to run it as a JUnit 4 test, it's a good compromise to get around trying it out. Okay, this is the end of the talk. The last slide. Let's summarize what we saw. At first, we talked about the basics, and we saw that the new API is like an incremental improvement. It has a lot of thoughtful new additions, a couple of things that are a little bit better than before, but nothing revolutionary yet, which I think is okay, because that part worked pretty well already. Then we got dynamic tests, which you can use to create parameterized tests or Lambda tests, even if you want to, with better tool support than before, because now a single test looks like a regular test to JUnit, and you can also do it in very fine-grained level. We saw the extension model, which already does a lot of things really well, and in general looks very promising. And it's also based on the awesome approach to say we want to do extension points. So we want to do as little as possible as a privileged part of JUnit. So for example, the disabled annotation that comes with JUnit is nothing special. It just uses the same extension point that we can use with disabled on Friday. So that means that that they have to really drive these extension points forward and make them as powerful as possible, so JUnit itself can create all the features that it wants. Okay, and then unfortunately, the best part, architecture. Sure, architecture which opens up the platform is, I think, the biggest selling point for JUnit 5, because we stand the chance that in a couple of years, all tools will be supported almost equally well, giving you a much wider range of choice, and also meaning that you can run all of them in the same test suite, yes, without any major drawbacks. You can just have tests from all kinds of frameworks if you want to. I mean, it can be hard for the team if you have 20 different test frameworks in there, but no technical reason is going to keep you from that. You can just put all your 20 frameworks in there, you put 20 test engines in there, and it all looks the same from the outside, looks really good with full tool support, which is not there yet. So you can't do this right now. At least not on the high level that you probably want to do. If you have like a small project that you just want to write a couple of tests for, then it's perfect, already do that. But in production, well, in production, but tests at work, if you have a complex project, then maybe you have some specific Usually you have some specific craft that developed over the time where you interact with JUnit 4 on a very specific level that JUnit 5 cannot yet cover, but it will soon, I'm sure. Okay, so usually I don't want to bore the people when we start the presentation, so I don't introduce myself. Simon already did that, so we're going to not talk about this slide. He said already where you can find me. Oh yeah, he didn't mention codefx.org where I write stuff. So other than that, now I'm open for all kinds of questions.
Okay, thank you very much, Nicolai. So, a couple of questions that we have in right now, just as my window refreshes. Here we go. MXSB, Max asks, a word on Hamcrest and assert J support.
So, as I said earlier, what assertions basically do is they just throw an exception, and then the JUnit framework realizes something's going wrong. It's just an exception which tells it that the test didn't pass, so it just fails the test and creates all the output and all that kind of stuff. So Hamcrest, assert J, all of them work out of the box within JUnit 5. That being said, it also means that usually these frameworks implement things quite differently. I think the only common denominator is the assertion error that they all use as the topmost level of their assertion exception hierarchy. I'm not sure though, but I think something like that is like a single exception or single error that's up there. And other than that, usually each framework uses different details. And the JUnit 5 team thought that this was not ideal and came up with something which didn't get a lot of traction yet. It's the open test platform. At the bottom of the hierarchy article, I said it's even more to the story. If you can later click on that, you go to a post where I explain that. I forgot the name right now, but what they wanted to do is they want to create a separate project which just defines like a handful or maybe more assertion errors, and then all the testing frameworks could depend on that very, very small artifact, and JUnit also could depend on that artifact and then get a little bit more information out of this assertion errors, so that support would get more detailed than it is now. But it's not yet better than before, but it's just the same. So you can just use all of these assertion libraries like Hamcrest if you're so inclined for whatever reason. But assert J, for example, yeah, sure, you can use all of them.
Okay, one question from Pans Hall G. How many CI servers support JUnit 5?
Good thing, maybe I should have looked that up earlier. In the JUnit project themselves, I saw no one that identified himself as being, for example, doing this for Jenkins team. I know that from the IntelliJ team, Anna Kozlova, I think is her name, she popped up a couple of times and opened some issues. So if someone from Jenkins did that too, I missed him. I didn't recognize him or her, but I'd say that it's also not there yet. And
Eugen commented afterwards, actually, on IRC saying any CI server that runs Maven and Gradle, so you can just invade the command.
Yeah, you can run that, of course. That part works. But if you want to have more support, yeah.
Native support, I guess, in a CI server, yeah.
Mm-hmm.
And those are the final questions that we have. We spoiled you with the number of questions. We don't normally have this many questions in our sessions, actually. So it's clearly a very hot topic. Okay, so if there's no other further questions, I'll leave it a couple of seconds. But if there's no further questions, it just leaves me to thank you very, very much, Nicolai, for your great session. A pleasure to have you on the VJug. And the next session, which is going to be on the virtual jug, is actually we've got 2 sessions in August. I haven't put them up on the Meetup site yet. We have one on the, I believe, I'm just going through from memory now, the 17th of August, which is Baruch from JFrog. He's going to be giving a Java 8 puzzler session, which is going to be good fun. The second session is Patricia, who's going to be giving a kind of hacking Java EE security session. I think that's around the 25th, 26th of August. I'll put that up this week, so do check that out. And of course, in September, I might do one session in September just because we have so many sessions that we need to get through, and then the final one, the final big September thing is going to be the VJug 24. So let me check if we've got any final questions in IRC. no final questions, but everyone saying thank you very much, and the Penn State shout out. There were 14 people. That sounds awesome. So thank you very much for gathering, and it's a great thing. It's actually one of the things that we wanted to do with the VJUG, to actually get people to encourage people to meet up in those kind of groups. So thank you very, very much for that. Now, Nicolai, I don't know if we mentioned this to you before, or if we're just about to ambush interview you, but we do these interviews with speakers straight after sessions, so do hang on the call, and our very own Oleg will be interviewing you shortly.
Yeah.
Awesome. Thank you very much, Nicolai. I hope you enjoyed the session. Thank you, Oleg, for handling Twitter and some of the questions. I appreciate all that. And thank you, everyone, for watching, and see you next time. Thank you.
Bye.
Thank you. Bye-bye.
Thank you for watching.